Welcome everyone. The question that is displayed on the screen, it came as a CBSE grade 12 physics question paper. The question number 6, the MCQ is, a metal rod of length 50 cm is held vertically and moved with a velocity of 10 meter per second towards east. The horizontal component of the Earth's magnetic field at the place is 0.4 Gauss. The EMF induced across the ends of the rod is option A 0.1 millivolt, option B 0.2 millivolt, option C 0.8 millivolt, and option D 1.6 millivolt. So here little bit basic we will discuss, and after that we will solve this problem. If there is a uniform magnetic field and that is perpendicular to that of the page, we will show it like this way, okay, by a dot within the circle. And now this region becomes a region of uniform magnetic field. Now if there is a rod, okay, a conducting rod made up of conductor, a metal rod, and that is of length L, okay, and if this rod is moved within this uniform magnetic field with a velocity v, then, and the magnetic field is B, then the EMF induced is B L V sin theta. Okay, if the movement of the rod and the magnetic field is completely perpendicular to each other, then theta equal to 90 degree. But if there is any angle, and that is theta, so sin theta, this factor need to multiply here. Now the next thing we have understood here, that is the horizontal component of the Earth's magnetic field. Okay, so obviously Earth is a large magnet. And what is the horizontal component of the Earth's magnetic field? Okay, if I consider this is the Earth's surface, okay, this is the North Pole and this is the South Pole, the magnetic lines of force obviously will be like this. Magnetic lines of force will be obviously like this, roughly. So at each and every moment it is not horizontal to that of the surface of the earth. Okay, so if we a person who lives in the North Pole, then it is completely like this. But if the person lives on the northern hemisphere like here, then in this particular cases maybe the magnetic field inclined at a certain angle with the earth's surface. Okay, if I say this is capital I, which is showing the intensity of the Earth's magnetic field, then it has two components, okay, like these two. This is called the vertical component and this is called the horizontal component. So Earth's magnetic field's horizontal component is like this way. And here in this question, the rod which is held vertically like this, and that is moved from west to east. Okay, that is moved from west to east. If I say this is the east, if I say this is my west, then this is the north and this is the south direction. Then the horizontal component of the Earth's magnetic field is something like this, and it is perpendicular to that of the motion of the rod. Let me draw. This is the direction of the movement, and the horizontal component of the Earth's magnetic field is something like this, and that is 0.4 Gauss. So here the direction of the movement and the direction of the horizontal component of the Earth's magnetic field is completely perpendicular to each other. So in this particular case, we can use the formula E equal to BLV because theta is 90 degree here. The length of the rod is 50 centimeter. So you can say that is 50 into 10 to the power minus 2 meter, and the velocity of the rod V is 10 meter per second, and the magnetic field is 0.4 Gauss. 0.4 Gauss means 0.4 multiplied by 10 to the power minus 4 Tesla. So if I put the value B is 0.4 multiplied by 10 to the power minus 4, 50 into 10 to the power minus 2, the velocity is 10 volt. So 0.4 into 5, 0.4 into 50, we can say that is 2. Okay, 5 into 4, 50 into 4 is 200, 200 into 0, so 20. 20 multiplied by 10 is 200. Now 10 to the power 4, 10 to the power minus 4, 10 to the power minus 2 is 10 to the power minus 6. So this will become 0.2 into 10 to the power minus 3. Okay, so that becomes 0.2 millivolt. Thank you all of you.